All right, so today we're going to do a little bit more with vectors. All right, so you've gotten a little bit of introduction to it. I'm going to make a couple of videos today. The first one is going to be to try to kind of start putting things together, just work through some problems, talk about some ideas, and we'll go from there. All right, so the first thing we're going to do is we're going to start with two vectors. We've got vector AB, which we're going to say has components of -2, 3. And then we've also got point A, which has coordinates of 3, 1. All right, so what we're going to do with this is we're going to just find a couple of things and talk about a couple of different ways to get through it. Let's first find AB. Okay, now when it's written this way with the AB there, that just means that we're finding the magnitude or the length of AB. Now, we recognize that AB is -2 in the x direction, which is going to go like this, -2, and then up 3 in the y direction. And so we're going to go up 3. And so it should be pretty easy then figure out how are we going to get the magnitude of that. Well, it's just simple Pythagorean, right? So we'll go -2 squared plus 3 squared, just like this. And that will then allow us to get our answer, which will be 4 plus 9 is 13, and so therefore we take the square root of both sides and we get the square root of 13 being the magnitude of AB. So AB there is 13. Alright, so now that we know the magnitude, let's see if we can find the location or the coordinates for point B. Alright, so there's a couple of different ways we can go about this. One is that we know if we have AB that we can simply go B minus A, and that should give us vector AB. Okay, so B, we don't know what the coordinates for B are, so that would just be xy minus A, which is 3, 1, should then give us AB, which is -2, 3. And so from there, we should be able to do our vector math. We add 3, 1 to the other side, and we get xy equals -2 plus 3 over 3, add the 1 to the other side, plus 1. And so therefore, xy is 1, 4. And so now we know the location of point B, which is 1, 4. Now there's actually another way that we can kind of think about this, and so let's pull out another color and we'll look at this another way. Because another way that we can do this is by just kind of using vectors and say, well, vector OB is equal to the combination of vector OA plus vector AB, right? And so essentially that then leads us in the same direction more or less, so that we can see, okay, well, that is going to lead us in this direction where we're saying that OB is that. So it's just another way to write it, another way to think about it. This is just using the points. This is using actual vector addition. And notice that since the A's are the same, the result is OB. Then from there you can fill in OB, which is your XY. You can fill in OA, and you can fill in AB. All right. What if I wanted to find the midpoint of AB? Okay, how would I get the midpoint of AB? Well, we can find how long half of the vector is. We can also just get the midpoint. Now that we have A and B, the midpoint's actually quite easy. All we need to do is take the x values and add them together and divide by 2. Find the average x value. And then we do the same thing, so XA and XB. And then we do the same thing with the y values. So we take the y value of A and the y value of B, and you average them together to find the middle y value. Okay, so that's one way to go about this, and we can go ahead and do that. So we got A, which was 3, 1, and then the B was 1, 4, and then we can find the point, just like this. So now we've got 4 over 2, which is 2, and 1 plus 4 is 5 over 2, which is 2.5. And so our midpoint is 2, 2.5. Now, other ways that you could do that, well, you could use half of vector AB, because if you've got point A and point B, and this is vector AB, how do you get to the midpoint? Well, it's just half then of AB. So if we start at A, which is 3, 1, and then we do half of AB, so 1/2 of vector AB would be considered to be half of negative 2 over 3. And here we get to see our scalar multiplication of a vector. And so we get negative 1 over 1.5. Sorry, not a fraction. So that would be half of AB right here. And so then you can just take the 3, 1 and add the negative 1, 1.5. So 3, negative 1 would give us 2. And then 1 plus 1.5 would give us the 2.5. And so again, we get the same midpoint one way by actually just looking at the points, and one way by thinking about it as a vector from A to B. The one thing to be careful of is to make sure that you don't use this as the midpoint. That's the vector from how do you get from point A to your midpoint. You could do a similar thing from B. You could subtract it and go the opposite direction. Okay? Anyway, so we've got through a couple of different ideas here, and let's maybe flip up. You know, we could stop there. I could stop this video, but let's just do a couple other things. Another idea that I want to look at is collinearity. So let's consider the points negative 1, 1, 1, 4, negative 5, negative 5, and 5, 10. So with those, what we want to do is find out, are they collinear? All right. So in order to find out if they're collinear, that means that they all need to be on the same line. Now, if 4 points are on the same line, then that means that, number one, that you have the same slope, right? If the slope is the same, that means that the vectors have to be multiples of each other, scalar multiples. So for example, if I've got A, B, C, D, if I want A, B, and C to be collinear, then the vector AB has to be equal to some scalar multiple of BC, right? Because this could be twice as long as it's going in the same direction, right? Or it could be half as long. So anything along those lines should work out. So what we're going to do is we're going to just show that each of these vectors gives us the same thing. So what we'll do first is we'll check AB. So we'll go from negative 1, 1 to 1, 4. So we'll go 4 minus 1, which is 3, and 1 minus negative 1, which is 2. So this is then vector AB, okay, where this is point A and this is point B. So in the x direction it goes to the right 2, and in the y direction it goes up 3. All right, so then we'll check another one. So let's go ahead and we'll check CD down here. And so we'll do the same thing. So I'll go, the x would be 5 minus negative 5, which would be 10. And then I'll go 10 minus negative 5, which would be 15. So that would be CD for me, right? When we do the vector, it's always the second point minus the first one. So 10 minus negative 5, 5 minus negative 5. I get 10, 15. And those aren't the same, but CD is equal to 5 times 2 over 3, which then is a scalar multiple. That's completing this. So what we've shown now is that A and B and C and D have the same vector, but that doesn't necessarily mean that they're all collinear, because A and B could be here and C and D could be over here. So the only way then to show that all 4 points are collinear is then to make some type of link between A, B, and C, D. So you can check A and C, or A and D, or B and C, or B and D, or anything along those lines, as long as you're making some link between those two. So let's go ahead and do that. Let's do BC. So again, I'll go negative 5 minus 4, which will be negative 9. So I'm doing BC here. So I'm doing C minus B. And then I'll do for the y value, sorry, I should have done that's the y value. So let's put that down on the bottom. And then the x value is negative 5 minus 1, which is negative 6. And you'll notice that I can take out the 3, which then leaves me again with 2, 3. So this is some pretty neat stuff. I mean, vectors, they're new, they're kind of fun, they're a little bit different at least than for what we've been doing. And it's, in a way, it's very visual. A lot of these things, you know, we're working algebraically, but you could just as easily draw them. Now, when you get to 3 dimensions, it does get a little bit harder. All right, so at this point, I'm actually going to go ahead and stop this video, and we'll do another one.